Two severe weather threats are building over the Gulf Coast at the same time, and the detail that matters most is not the heat or the rain by itself. It is the way one threat is making the other far deadlier. Right now, a hazardous heatwave is forcing the regional electrical grid to its absolute limits. Directly behind it, a training storm mechanism is locking into place, threatening to drop catastrophic rainfall over cities that cannot drain without continuous electricity. Stay with me, because the part that most people will miss is the one that turns a bad forecast into a structural trap. If this has you concerned, subscribe to Rupture, because this is the kind of pattern recognition the evening news is not giving you. Drop a comment below and tell us this. When was the last time your local broadcast read directly from a National Weather Service forecast discussion? On June 14, 2026, the National Weather Service Weather Prediction Center released a forecast discussion that used one word to describe what is heading toward the Gulf Coast. And that word was not dangerous, it was not excessive, and it was not extreme. The word was hazardous. And the sentence in which it appeared did not describe a new system arriving from somewhere else. It described a relocation. Let me show you what that means. The week before this discussion was filed, Portland sat under a ridge that pushed temperatures 25 degrees above normal and drove readings near 99 degrees in a city built for far milder summers. That is the calibration baseline, and it matters because the same ridge is now over Houston, New Orleans, Mobile, Tallahassee, and Tampa, where the nights do not cool the way they did in Oregon. The Weather Prediction Center gave that movement a single operational label: hazardous heat shift from the west and southwest to the south. That is not the word a meteorologist uses casually. It is not a synonym for hot. It sits inside a specific operational hierarchy at the National Weather Service, and part 2 of this video will walk you through that hierarchy in detail. For now, what matters is this. The ridge that drove a city in Oregon to 25 degrees above normal has been formally classified as hazardous when applied to the Gulf South. And the reason that classification is so much more severe in the Gulf than it was in Portland is the one detail almost no broadcaster has mentioned: the overnight low. In Portland, when the ridge sat overhead and temperatures pushed toward 99 in the afternoon, the air cooled in the evening. Nighttime readings dropped into the low 60s. The human body, which is to say the cardiovascular system of every adult over the age of 55 sitting in a Portland living room, had a window of recovery every 24 hours. The heat broke. The body cooled. The window closed. In Houston this week, the overnight low does not drop below 80 degrees. Let that sit for a moment. The same ridge. The same atmospheric driver, but in a region where the nighttime air refuses to release the heat it absorbed during the day. The Gulf South is not just hotter than Portland. It is structurally different. It does not have a recovery window. The body is asked to cool itself in air that is already warmer than the inside of a refrigerator, with humidity readings that prevent sweat from evaporating off the skin. That is not a weather story. That is a physiological emergency in slow motion. And here is what the Weather Prediction Center did when they saw that. They filed the word hazardous into an operational discussion that meteorologists in every regional forecast office read every morning. They did not issue a press release. They did not call a news conference. They wrote the word into a document that has been publicly available since June 14. And that document has been sitting on the National Weather Service website while every cable news broadcast in the country used the phrase heat returns or summer heat wave or heat dome without ever pulling the actual operational language. Heat dome is a meteorology term. It describes the physical mechanism, which is to say a ridge of high pressure that traps warm air near the ground and prevents it from rising and dispersing. The phrase is accurate, but it is also generic. It does not tell you which heat dome, or how strong, or how long, or what the agency monitoring it has called it. The word hazardous tells you those things. The phrase heat returns does not. This is the gap. The official document and the public broadcast are not describing the same event. The official document says hazardous heat shift from the west and southwest to the south, and it specifies a 5-day window in which the threat reaches the highest operational tier the agency uses. The public broadcast says heat is moving back into the south this week. One of those sentences contains an actionable severity classification. The other one is a weather report. Let me give you one more piece of the ridge's track record before this part closes. because the Portland number is only one half of the calibration. In the days that ridge sat over the Pacific Northwest, the agencies that track infrastructure stress recorded warning level activity at multiple regional power utilities. The grid in the Northwest is not designed for sustained 90-degree-plus afternoons. Air conditioning loads surged. Transmission lines, which is to say the high-voltage cables that carry electricity across long distances, were derated. That is the operational term for a power line that has to carry less electricity than its rated capacity, because the surrounding air is too warm to allow the cable to safely shed its heat. The line itself becomes part of the problem. Heat constrains the grid that the population needs to escape the heat. That ridge is now over a region where the grid is older. The housing stock is older, the population is older, and the overnight load does not drop below 80. The same ridge, a different city, a different consequence. By the morning of June 15, regional forecast offices from Houston to Tallahassee had begun preparing public messaging for a heat event that the Weather Prediction Center had already classified at the hazardous tier. By the afternoon of June 15, the first heat advisories began to issue, but none of them used the word the central agency had used. The word hazardous remained in the operational document. The public-facing language softened. That is not a translation. That is an attenuation. The story everyone is covering this week is the heat. The story almost nobody is covering is that the heat is the second appearance of an atmospheric driver that has already demonstrated in a different city what it does when it sits overhead and refuses to move. Portland was the rehearsal. The Gulf Coast is the show. And the question this part leaves unanswered, the question part 2 will answer in operational detail, is this: what does a ridge with that track record do next when it arrives in a region where the nighttime air never cools below 80 degrees and the agency monitoring it has already used the word the public has not heard? The answer is in the word itself. But before we get to the word, you need to understand the hierarchy it sits inside. Because hazardous is not the top of a casual scale, it is the top of a structured one. And the difference between the word hazardous and the words you have actually heard from your local broadcaster this week is the difference between a forecast and an instruction. Remember where part 1 left it. The same ridge that drove Portland to 99 degrees is now aimed at a region where the nighttime air never cools below 80, and the agency responsible for protecting American lives has already assigned it a severity classification that did not reach a single evening broadcast. Now you need to understand what that classification actually means inside the operational architecture of the National Weather Service. Because the word hazardous is not a casual descriptor. It is the top of a specific hierarchy, and the hierarchy has rules. Let me walk you through it. The National Weather Service uses 4 primary public communication tiers for heat events, and they escalate in a specific order. The first tier is the heat advisory. A heat advisory is issued when the heat index, which is to say what the air actually feels like to the human body when humidity is factored in, not the thermometer number, but the number your body experiences, is expected to reach values that pose elevated risk to vulnerable populations. The threshold varies by region. In the Gulf South, a heat advisory typically triggers at a heat index between 105 and 109 degrees. That is the language your local broadcaster uses most often. It is the floor of the operational hierarchy, not the ceiling. The second tier is the excessive heat watch. An excessive heat watch is issued when conditions are favourable for an excessive heat warning within the next 24 to 72 hours. It is a preparatory tier. It tells emergency managers in a given region that they need to begin staging cooling centres, contacting elderly residents, and coordinating with utility providers. The watch itself does not require public action. It requires institutional readiness. The third tier is the excessive heat warning. An excessive heat warning is the operational tier that triggers the most aggressive public messaging. It is issued when the heat index is expected to reach or exceed values that pose immediate threat to human life, typically 105 to 110 degrees or higher, sustained for 2 or more consecutive days. The excessive heat warning is the tier the public has heard most often during major Gulf Coast events. It is the tier that produces the red banners across the bottom of cable news broadcasts. It is the tier emergency managers use to activate the full institutional response. And then there is the fourth tier. The fourth tier does not have a single uniform name in the public-facing system, because it is not primarily a public-facing tier. It is the operational language the Weather Prediction Center uses in its forecast discussions when it wants to flag an event that exceeds the parameters of a standard excessive heat warning. The word it uses is hazardous, and the word hazardous in the operational language of the agency denotes a heat event that meets or exceeds excessive heat warning criteria, but with additional risk factors layered on top. Duration, geographic scope, compound threats, vulnerable population concentration, infrastructure stress. The word hazardous, in other words, is what the agency uses when an excessive heat warning is not enough. Now let me give you the comparison baseline. In the summer of 2024, the Gulf Coast experienced an excessive heat warning event that produced heat index values between 110 and 115 degrees. That event lasted approximately 8 hours at peak intensity. It was the kind of event that produced the red banners, the cooling centre activations, the elderly welfare checks, and the public messaging that most viewers will remember. It was, by every measure, a serious operational event. And the Weather Prediction Center did not, at any point during that event, use the word hazardous in its national forecast discussion. The current event is being classified at the hazardous tier across a 5-day window. That is the comparison. 8 hours at the excessive heat warning tier in 2024 versus 5 days at the hazardous tier in 2026. The 2024 event produced the most aggressive public messaging the Gulf Coast had seen in years. The 2026 event has produced, in the same news cycle, the phrase summer heat wave. This is the operational gap. The agency that is responsible for warning the American public of life-threatening weather has classified the current event one full tier above the most severe event of the previous summer. And the public messaging, which is to say what your local broadcaster is reading off the teleprompter, has not reflected that escalation. The broadcaster is still using the language of a standard heat event. The agency is using the language of an event that exceeds the standard. Let me be specific about how this happens, because it is not the result of any single bad actor. The Weather Prediction Center files its forecast discussions in technical language intended for other meteorologists. The regional forecast offices then translate that language into public messaging through advisories, watches, and warnings. Local broadcasters then translate that messaging into the sentences they read on the evening news. At each translation step, the language softens. The word hazardous appears in the WPC document. The regional offices issue excessive heat warnings, which is the strongest public-facing tier they have routine authority to issue. The local broadcasters report excessive heat warnings as heat advisories or heat alerts, because the average viewer cannot distinguish between an advisory and a warning, and the broadcaster compresses the difference. By the time the language reaches the viewer at home, the word hazardous has been attenuated 3 full steps. That is not a translation. That is an erosion. And the erosion has a consequence. The American Meteorological Society, which is to say the professional organization that sets the standards for how weather risk is communicated in the United States, has been documenting this attenuation problem for over a decade. Their findings are clear. When operational severity language is softened in the transmission from agency to public, the public response is calibrated to the softened language, not to the operational reality. A viewer who hears heat advisory prepares for a heat advisory. A viewer who hears hazardous heat prepares for something else. The same physical event produces different public behaviours depending on which word reaches the living room. This is gap 1. The official document used the word hazardous. The mainstream coverage used the phrase heat returns. And there is no mechanism in the current system that requires the broadcaster to read the operational language directly. The agency files the word. The translation chain attenuates it. The public hears the softened version. And when the event arrives, the public is calibrated to the softened version, not to the operational tier the agency actually assigned. Let me give you one concrete example of what this looks like at the household level. A retired couple in the Houston metropolitan area, both in their late 60s, both with managed chronic conditions, watching the evening news on a Sunday night. The broadcaster mentions that a heat advisory has been issued for the work week. The couple has lived in Houston for 40 years. They have heard the phrase heat advisory hundreds of times. They have a window unit air conditioner in the bedroom that has worked through every previous heat advisory. They make no additional preparation. They do not contact their adult children. They do not stock additional water. They do not identify a nearby cooling center. The agency that filed the operational document used a word that, if the couple had heard it, would have produced a different response. The couple did not hear that word. That is the cost of the attenuation. It is not abstract. It is a household decision tree that branches differently depending on which word reaches the kitchen table. And the responsibility for which word reaches that kitchen table is distributed across so many institutional links that no single link can be held accountable when the wrong word arrives. The Weather Prediction Center will say, correctly, that they filed the operational language and made it publicly available. The Regional Forecast Office will say correctly that they issued the strongest public-facing tier they had routine authority to issue. The local broadcaster will say correctly that they reported the heat advisory that the regional office issued, and the retired couple in Houston will say, if they are asked afterward, that they had no idea this event was different from any other heat event they had lived through. So who carries responsibility when the official severity word is filed and not reported? The answer is that nobody does, under the current architecture. The word hazardous sits in the document. The document is publicly available. The chain of translation does its work. And the public is informed of a softened version of the truth. But the document remains. And the document said what it said. And by the time you finish this video, you will have read the operational language directly, which means you will know what the broadcaster did not tell you. That is what Part 3 is for. Because the word hazardous is not the only word in that document that did not reach the broadcast. There is another phrase. 3 words, and those 3 words are the reason this video exists. Let me introduce you to a phrase that appears exactly once in the official June 14 forecast discussion. 3 words that have never appeared in any television broadcast covering this event, and that have appeared before in exactly the kind of situation you're about to hear described. The phrase is repeat and training of storms. 3 words filed by the Weather Prediction Center on the morning of June 14, 2026, in the same operational document that classified the heat at the hazardous tier. 3 words that describe a specific atmospheric mechanism and that have a specific historical track record in the Gulf South. You need to understand what training storms are. Most viewers, when they hear the phrase, picture a single storm system passing over a region and dropping its rain as it moves. That is the standard mental model of how rainfall works. A storm forms. It moves. It rains. It exits. The rain stops. The ground absorbs what fell, the drains carry away the rest, and the event ends. That is how most rainfall in the United States behaves, and it is the mental model that most people use when they hear the word storm in a forecast. Training storms do not behave that way. In a training storm event, multiple storm cells form along the same atmospheric track and move along that track in sequence, one after another, dropping rain on the same geographic footprint over and over. The mechanism is called training because the storms move along the track the way railroad cars move along a train. The lead cell drops its rain. A second cell follows along the same track and drops its rain on the same streets. A third cell follows. A fourth. Each cell is its own storm. Each cell dumps its own rain total, and the geographic footprint underneath the track receives the cumulative total of every cell that crosses it. Let me give you the household analogy. Imagine a convoy of trucks, all carrying water, all driving across the same bridge. A normal storm event is one truck crossing the bridge and emptying its tank as it crosses. A training storm event is 50 trucks crossing the same bridge in sequence, each one emptying its tank on the same span. The bridge does not get 50 times the water spread across 50 bridges. The bridge gets 50 times the water on one bridge. That is the mechanism. And it is the most dangerous flash flood mechanism in operational meteorology. The agencies that monitor flood risk in the United States have documented this. The National Weather Service Flash Flood Research Program has confirmed that the overwhelming majority of catastrophic rainfall events in the Gulf South, which is to say events that produce 20 inches or more of rain in a single geographic area over a short window, involve training storms as the primary mechanism. Not hurricanes, not tropical depressions, training storms. And the most famous training storm event in modern American history happened in August 2017. You know the name of that event. The name is Harvey. But what you may not know is that Harvey as a tropical system made landfall on the Texas coast and weakened rapidly after coming ashore. By the time the rainfall totals that defined Harvey began to accumulate in Houston, Harvey was no longer a hurricane. It was a weakened tropical depression sitting offshore, feeding moisture into a stalled atmospheric pattern that produced training storms over the Houston metropolitan area for 4 consecutive days. The 60 inches of rain that fell on Houston during Harvey were not produced by the hurricane. They were produced by the training storm mechanism that the hurricane's residual moisture fed. The word Harvey is what the public remembers. The mechanism that produced the rainfall is what the forecasters remember, and the phrase in the operational forecast discussion that preceded the worst of the Houston flooding was the same phrase that appears in the June 14, 2026 document. Repeat and training of storms. That phrase was in the National Weather Service forecast discussion for Houston in the 72 hours before the 60-inch rainfall total began to accumulate. The phrase was publicly available. The document was publicly available. The mechanism was named in the operational language. And almost no broadcast coverage of the approaching event used the phrase. The coverage used the name Harvey. The coverage tracked the hurricane. The coverage did not pull the mechanism language out of the document and put it on television. 60 inches of rain. On a single American city. In 4 days. The death toll from Harvey reached 107 people. The economic damage exceeded $125 billion. The flooding displaced more than 30,000 residents and damaged more than 200,000 homes and businesses. And the mechanism that produced those totals was named in the operational document before the rain began. The 3 Houston residents whose names appear in the early flood casualty reports were not warned about the training storm mechanism. They were warned that a hurricane was approaching. They prepared for a hurricane. They sheltered in place for a hurricane. They did not evacuate because hurricane preparation in Houston has been refined over decades, and shelter in place is the standard response for a Category 3 system. The hurricane came ashore. The hurricane weakened. The hurricane appeared to be ending, and then the training storms began. They did not know it was coming. They did not know the forecast had named it. They did not know the word training meant their street would flood a second time before the first flood had drained. That is the mechanism. That is what the 3 words mean. And those 3 words are in the document again. Now here is the structural escalation, and this is the point of this part. Harvey was a named storm. Harvey arrived with a hurricane category attached to it. Harvey had a name on television for 3 days before the rain began. The current event has none of those things. The June 14 forecast discussion describes a repeat and training of storms threat over the Gulf Coast that is not tied to a named storm. There is no hurricane offshore. There is no tropical depression. There is a Gulf disturbance the mainstream coverage has mentioned in passing, with a low probability of tropical development. The training storm mechanism does not require tropical development. It requires a stalled atmospheric pattern and a moisture source. The Gulf Coast has both. That is the difference. In 2017, the public had a hurricane to focus on. The training storm mechanism rode in on the hurricane's name, and the public did not see it coming because the hurricane drew the eye. In 2026, there is no hurricane. There is no name. There is no Category 3 system to focus the news cycle. There is only an operational document, 3 words, and a region where the same mechanism is already documented as the primary flash flood threat for the next several days. A training storm event does not need a hurricane. It needs a pattern. The pattern is in place. The Weather Prediction Center filed the language. The mechanism is named. The geography is the same Gulf Coast that absorbed 60 inches in 2017, and the public, watching the same television networks that did not pull the language out of the document in 2017, is being told this week that a heatwave is moving in and a Gulf disturbance might produce some rain by the weekend. That is not the forecast. That is the absence of the forecast. The forecast says repeat and training of storms. The coverage says some rain possible. The forecast says hazardous heat. The coverage says heat returns. The forecast describes a compound event. The coverage describes 2 unrelated weather stories. And the question that ends this part is the same question that ended part 1 in a different form. How many Gulf Coast residents know that a flood can begin without a hurricane name attached to it? The answer is almost none, because the entire public mental model of Gulf Coast flooding is calibrated to hurricane season, to named storms, to the cone of uncertainty, to the Saffir-Simpson scale. The mental model does not include a training storm event arriving in a week when no named system is on the map. The mental model does not include a Gulf disturbance that is not a hurricane producing 20 inches of rain on a city that prepared for a hot week. The mental model is wrong. The mechanism does not care about the mental model. The mechanism behaves according to the atmospheric pattern, and the atmospheric pattern is in place. 3 words. In a document. Released on June 14, not read on a single broadcast. Those 3 words have been in a document before. And the last time they were, 60 inches of rain fell on Houston. The next part of this video will explain why the engine driving the current event is not just the same as Harvey. It is hotter, it is closer, it is 2 months earlier than it should be, and it is sitting under the Gulf of Mexico right now, waiting for the pattern overhead to do what the pattern overhead is already documented as doing. Before a single storm cell has formed over the Gulf Coast this week, before the first flood warning has been posted, before the first heat advisory has been issued for Texas or Louisiana, the Gulf of Mexico itself is already running at temperatures it has historically not reached until the last week of July. The current sea surface temperatures across the central and northern Gulf are sitting near 80 degrees Fahrenheit, with multiple zones running as much as 3 degrees above the seasonal average for mid-June. 3 degrees does not sound like a lot. In this context, it is the difference between a forecast and a setup. Let me translate the term. Sea surface temperatures, which is to say the temperature of the water at the surface of the Gulf, the layer that directly feeds moisture and heat into any storm that crosses it, are the single most important variable in determining how much rainfall a Gulf-fed storm system can produce. The water at the surface is the fuel. Warmer surface water means more evaporation. More evaporation means more moisture in the lower atmosphere. More moisture in the lower atmosphere means more rainfall when that moisture is lifted and condensed by a storm system overhead. The relationship is not linear. It accelerates. For every degree Fahrenheit of additional sea surface temperature, the atmosphere above that water can hold approximately 4% more water vapor. That is the Clausius-Clapeyron relationship, named for the physicists who derived it in the 19th century, and it is not a forecast model, it is physics. 3 degrees above normal means roughly 12% more available moisture for any storm system that draws from that water. 12% is the difference between a heavy rain event and a flood. 12% is the difference between 4 inches and 4.5 inches in a single hour. 12% is the difference between drainage that handles the load and drainage that does not. The Gulf is currently running 3 degrees above normal. Yale Climate Connections, which is to say the climate communication arm of one of the most rigorous environmental research programs in the United States, used a single word to describe the current Gulf surface temperatures. The word was startling. That is not a journalistic embellishment. That is a scientist choosing the word startling in a peer-reviewed communication context where language is chosen conservatively, where the standard adjective is anomalous or elevated, and where the word startling has to be earned. It was earned. The Gulf is at temperatures it does not normally reach until August. The publication that monitors this for a living chose the word startling. There are 2 mechanisms by which this matters, and you need to understand both. The first mechanism is storm fuel. The training storm threat documented in the June 14 forecast discussion does not exist in a vacuum. Every storm cell that forms along the Gulf Coast this week will draw its moisture from the water below. The water below is hotter than it should be. Each cell will load more moisture into its updraft, condense more rain in its downdraft, and deposit more water per square mile on the geography below. The training storm mechanism takes that per cell increase and multiplies it across multiple cells crossing the same footprint. 12% more per cell. 50 cells crossing the same neighbourhood. The math compounds. The second mechanism is the nighttime cooling failure. This is the mechanism that targets the elderly population on the Gulf Coast specifically. The Gulf, when it is at its normal mid-June temperature in the mid-70s, allows the air above it to cool during the overnight hours. Coastal communities historically experience a nighttime temperature drop of 10 to 15 degrees as the air cools and the marine breeze brings in air from over the cooler water. That drop is the recovery window. It is what allows a cardiovascular system that has been stressed all day to rest overnight. It is what allows a window unit air conditioner to catch up. It is what allows the inside of an uninsulated house to release the heat it absorbed during the day. When the Gulf is at August temperatures, the recovery window closes. The marine breeze still arrives, but the air it brings is warmer because the water it has been sitting over is warmer. The overnight low does not drop 15 degrees, it drops 5, or 3, or none. The house does not cool. The window unit cannot catch up because it never had a chance to. The cardiovascular system that was stressed at 105 degrees during the day does not rest at 82 degrees overnight. It stays stressed. It accumulates damage. And on day 3 or day 4 or day 5 of the event, it fails. That is not a heat statistic. That is a physiological mechanism with a specific trigger and a specific timeline. The Centers for Disease Control have documented the timeline. Heat-related mortality in elderly adults follows a delayed curve. The deaths do not occur on day 1 of a heat event. They occur on day 3, day 4, and day 5, after multiple nights without adequate cooling have accumulated stress on the cardiovascular system. The Gulf water temperature this week is the variable that determines whether those nights provide recovery or extend the stress. The water is at August temperatures. The recovery window is closed. The clock that begins on day 1 of this event runs straight through to day 5 without resetting. This is what the broadcasters mean when they say the overnight low will be 80 degrees this week. They mean the Gulf is too hot to let the air cool. But they do not say it that way. They say it as a temperature reading, which is to say a number on a chart, not a mechanism with a consequence. The number on the chart is 80 degrees. The mechanism is that the body cannot recover. The consequence is that elderly residents in older housing on the Gulf Coast will die on day 4 of this event, not day 1. The death will be attributed to heat. The mechanism that produced it will be the water temperature in the Gulf. Let me give you one named region zoom. In the Galveston Bay area, where the elderly population concentration is among the highest in the Texas coastal corridor, and where the housing stock includes a significant percentage of homes built before 1980 with limited insulation and aging air conditioning systems, the nighttime overnight low is forecast to remain at or above 80 degrees for the entire 5-day window of the event. That is not a forecast for one bad night. That is a forecast for 5 consecutive nights without recovery. The Gulf below that geography is the engine driving that forecast. The Gulf is at August temperatures. The engine is already on. And here is the seasonal implication. If the Gulf is at August temperatures in the second week of June, the question that should be asked, and that the mainstream coverage has not asked, is what the Gulf looks like in August. The water does not cool down. It accumulates heat through the summer. June is the warm-up, July is the build-up, August is the peak. If the current peak is being reached in June, the August peak is being added to a baseline that is already 3 degrees above where it should be. The numbers compound. The fuel supply for late summer Gulf storms is being loaded into the water now, 2 months early. The hurricane forecasters know this. The National Oceanic and Atmospheric Administration issued its 2026 hurricane season outlook with above normal activity probabilities that explicitly cited Gulf sea surface temperatures as the primary driver. The forecast was issued before the Gulf reached its current readings. The current readings exceed what the forecast assumed. The forecast is already conservative. If this is what June looks like in 2026, what does August look like? That is the question that closes this part. It is not a rhetorical question. It is the seasonal frame that Part 8 of this video will return to in detail when the El Niño Declaration and the CPC Hazard Outlook are introduced. For now, what matters is this. The water below the storm track that the Weather Prediction Center has already classified at the hazardous tier is at temperatures it does not normally reach until late July. The training storm mechanism named in the forecast discussion will draw its fuel from that water, and the nighttime cooling window that elderly Gulf Coast residents depend on for survival during heat events is closed before the event has begun. The heat is real. It is measured. It is already here, and it is already moving. Part 4 ended with the Gulf water at August temperatures in mid-June, and the question of what that means for the storms that follow. Here is what the official forecast document already tells us about the storms that are already following. The June 14th, 2026 Weather Prediction Center forecast discussion contains a single sentence that almost no mainstream outlet has quoted. The sentence attributes both the hazardous heat threat and the excessive rainfall threat to the same atmospheric driver. The driver is described in the operational language as a highly anomalous upper air pattern. Let me translate that phrase. An anomalous upper air pattern, which is to say the atmosphere above 20,000 feet, has locked into a configuration that does not behave the way it should for this time of year, is the operational term meteorologists use to describe a stalled or distorted jet stream. The jet stream is the river of fast-moving air that sits in the upper troposphere and steers weather systems across the continental United States. When the jet stream is behaving normally, it carries weather from west to east at a predictable speed and shape. When it is anomalous, it stalls, it loops, it forms ridges and troughs that lock geographic regions under the same weather pattern for days or weeks at a time. The current pattern over the United States is one of those stalled configurations. The ridge over the Gulf South is the heat producer, the same atmospheric driver, on its eastern and northern flank, is producing the trough that lifts Gulf moisture northward into the central United States. The two features are not separate. They are two sides of the same configuration. A ridge cannot exist without a trough adjacent to it, the way a hill cannot exist without a valley beside it. The ridge bakes the Gulf South. The trough drags moisture out of the Gulf and dumps it on the geography to the north. The atmosphere does not see two stories. The atmosphere sees one pattern with two effects. That is the compound event. The Weather Prediction Center document states this in operational terms. The same paragraph that classifies the heat at the hazardous tier also describes the excessive rainfall threat extending from the northern Midwest down through the Central Plains and into the Gulf Coast. One paragraph. One driver. Two simultaneous threats. The document does not present the heat and the flooding as two separate stories. It presents them as outputs of the same atmospheric configuration. That is not two weather stories running alongside each other. That is one atmospheric event with two faces. Let me map the corridor in words. The northern edge of the threat sits over Minnesota, Wisconsin, and Iowa, where the moisture lifted out of the Gulf is being dropped as excessive rainfall in the central Midwest. The middle of the corridor runs through Missouri, Kansas, and Oklahoma, where the boundary between the heat ridge to the south and the moisture flow from the north produces the conditions for training storm development. The southern edge of the corridor sits directly over the Gulf Coast, from the Texas-Louisiana border across to the Florida Panhandle, where the heat ridge produces hazardous heat during the day, and the training storm mechanism produces flash flooding when storm cells cross the same footprint. That corridor is approximately 1,500 miles long. 1,500 miles is the distance from Minneapolis to New Orleans. 1,500 miles is the distance from Houston to the eastern edge of the Florida Peninsula. It is a continuous geographic stretch in which the same atmospheric driver is producing different but related hazards, and it crosses three federal emergency management agency regions: FEMA Region 4, which covers the southeastern states including Florida, Georgia, Alabama, and Mississippi; FEMA Region 6, which covers the south-central states including Texas, Louisiana, Arkansas, and Oklahoma; FEMA Region 7, which covers the central states including Missouri, Iowa, Kansas, and Nebraska. Three regions. One pattern. The simultaneous activation requirement is what makes this a structural problem rather than a forecast problem. The Federal Emergency Response Architecture was designed under the assumption that disasters happen in geographically contained areas. A hurricane hits the Gulf Coast, a wildfire burns through California, a tornado outbreak strikes the Central Plains. Each disaster activates a specific FEMA region, which draws resources from adjacent regions that are not currently activated. The architecture works because at any given time, most of the country is not in disaster mode and can serve as a resource pool for the part that is. A 1,500-mile continuous threat corridor breaks that assumption. If FEMA Region 4 is activated for hazardous heat and training storm flooding across Florida and the southeastern coast, and FEMA Region 6 is activated for the same threats across Texas and Louisiana, and FEMA Region 7 is activated for excessive rainfall and flooding across the central Midwest, The resource pool that each region normally draws from is itself activated. The architecture loses its redundancy. The mutual aid agreements that normally provide National Guard units, electrical line crews, swift water rescue teams, and emergency medical resources across regional boundaries cannot function when all three regions are demanding the same resources at the same time. That is the gap. The Weather Prediction Center filed one document describing one pattern. The Federal Emergency Response Architecture is designed to respond to one disaster at a time per region. The current event is one pattern producing simultaneous threats across three regions. The architecture is being asked to do something it was not designed to do, and no mainstream outlet has connected the Midwest flood coverage to the Gulf heat coverage as components of a single atmospheric event. 4 separate news stories were written about 4 components of a single pattern: Iowa flooding, Houston heat, Florida humidity, Gulf disturbance. None of them mentioned each other. None of them quoted the WPC document that connects them. None of them named the highly anomalous upper air pattern that produces all 4. That is Gap 4. Let me give you the household frame for why this matters. A retired couple in Tampa watching the evening news learns that Iowa is experiencing flooding. They feel sympathy. They do not connect it to their own forecast. A retired couple in Iowa watching the same broadcast learns that the Gulf Coast is experiencing extreme heat. They feel sympathy. They do not connect it to their own forecast. Both couples are watching the same weather system produce both events. Neither couple is told that the 2 events are linked. Both couples calibrate their preparation to the local forecast. Neither couple understands that the system producing the local forecast is the largest atmospheric event in the continental United States this week. The information is in the document. The connection is not in the coverage. And the question that closes this part is the structural question that the next part will answer in concrete terms. Was the National Emergency Response System designed for a 1,500-mile simultaneous activation? The answer is no. The system was designed for the assumption that adjacent regions could backstop each other. When the pattern producing the disasters is itself 1,500 miles wide, the adjacent regions are not available to backstop anything. They are activated too. And the geographic point in that corridor where the failure of mutual aid creates the most immediate human consequence is the city that has spent the most money on the most specialized flood control infrastructure in the United States. That city is New Orleans, and the way it floods is not the way you think it does. Let me ask you a question that when you first hear it sounds like a city planning problem, not a weather problem, but by the end of this part, you will understand why it is the most important infrastructure question on the Gulf Coast right now. The question is this: how does a city below sea level get rid of the water that falls on it during a storm? The answer is not gravity. The answer is electricity. New Orleans does not drain. New Orleans pumps. The city sits in a geographic bowl. Approximately half of the metropolitan footprint is at or below sea level, with elevations ranging from 1 foot below sea level in the higher neighbourhoods to 6 feet below sea level in the lowest sections of the city. There is no downhill direction for water to flow. There is no river the water can run into, because the river itself, the Mississippi, is held back from the city by a levee system that prevents the river from entering the streets. The water that falls on New Orleans during a storm has nowhere to go. It sits on the ground until something pushes it out. That something is the pumping system. New Orleans operates 24 major pumping stations distributed across the metropolitan footprint that move stormwater out of the city's drainage canals and lift it over the levees into Lake Pontchartrain to the north, or into the marshes east and west of the urban core. The pumps themselves are massive industrial machines, some of them dating to the early 20th century, designed to move billions of gallons of water per day during peak rainfall events. The combined pumping capacity of the system is approximately 1 million gallons per second when all 24 stations are operating at full capacity simultaneously. Every one of those pumps requires electricity. The pumping stations depend on electricity, and that is the city's weak point. New Orleans can have the right levees and still flood if the pumps lose power during heavy rain, which is exactly what happened in August 2017 when a training storm dumped 5 to 9 inches on the city and exposed the failure mode in real time. Not Katrina. The August 2017 event. Katrina is the disaster that the public remembers, and the public mental model of New Orleans flooding is calibrated to Katrina. Levees failing, storm surge entering the city, catastrophic flooding produced by a Category 5 hurricane. That is the wrong mental model for this week. The current threat does not require a Category 5 hurricane. It does not require a Category 1 hurricane. It does not require a tropical storm. It requires a training storm event over the city and a power failure at any significant percentage of the pumping stations during the rainfall. The June 14 forecast discussion has placed the training storm threat over the Gulf Coast. A hazardous heat threat in the same document has placed the regional power grid under maximum stress during the same window. Let me build the dual demand scenario. During the daylight hours of a hazardous heat event, electrical demand across the Entergy New Orleans service area surges as residents run air conditioning at maximum capacity. Commercial buildings demand peak load. Hospitals and assisted living facilities cannot reduce demand without risking patient safety. The grid operates near its maximum capacity for sustained periods. Transmission infrastructure, which is to say the high-voltage cables that carry electricity from generation stations to the distribution network that reaches individual buildings, operates at elevated temperatures, which reduces its carrying capacity and increases the probability of failure. During the rainfall hours of a training storm event over the same city, the pumping stations demand power at the moment when the grid is already stressed. The pumps are typically not the highest priority load on the grid, which means that during a grid stress event, the pumps may be deprioritized in favor of residential and medical loads. If the pumps are deprioritized, the water rises. If the grid fails entirely, the pumps stop and the residential and medical loads lose power simultaneously. The cooling stops. The pumping stops. The cooling and the drainage fail at the same time. That is the scenario. The current event has placed both demands on the same grid in the same window. The hazardous heat will stress the grid during the day. The training storm threat will demand pumping during the rain events that the same atmospheric pattern is generating. Both demands draw from the same electrical infrastructure. Both failures, if they occur simultaneously. That is not a flood scenario. That is not a heat scenario. That is a city below sea level, without power, in 105-degree air, with no way to drain the streets and no way to cool the rooms, and 383,000 people waiting for someone to tell them what to do next. 383,000 is the population of the city of New Orleans. The metropolitan population, which is to say the people in the surrounding parishes who depend on the same infrastructure for evacuation routes, hospital access and emergency services, exceeds 1,200,000. The evacuation routes themselves run through low-lying areas. Interstate 10, the primary east-west evacuation corridor, crosses sections of marshland that are vulnerable to flooding during exactly the kind of training storm event the forecast discussion names. Interstate 55 to the north and Interstate 59 to the northeast are the alternate routes, and both cross flood-prone terrain in their early miles out of the city. Now factor in the heat. An evacuation conducted in 105-degree heat index conditions is not the same as an evacuation conducted in normal weather. Vehicles overheat. Elderly evacuees in vehicles without functioning air conditioning suffer heat stroke within hours. Pets cannot be left in vehicles. The infrastructure that supports evacuation, including gas stations, rest stops, and emergency shelters along the evacuation corridor, requires power. If the same grid stress that affects New Orleans extends along the evacuation corridor, which it does under the current pattern because the pattern itself is 1,500 miles wide, the supporting infrastructure along the route is also degraded, so the evacuation impossibility question becomes concrete. 383,000 people. 105-degree heat index. Streets flooded. Power out. Pumping stations offline. Hospitals on backup generators that have a limited fuel supply. Assisted living facilities with elderly residents who require continuous air conditioning to survive. Evacuation routes that are themselves degraded by the same pattern that is producing the emergency in the city. And no adjacent FEMA region available to provide mutual aid, because all adjacent FEMA regions are activated for the same event. That is the scale. The city of New Orleans has spent over $14 billion on its post-Katrina flood control infrastructure. The hurricane and storm damage risk reduction system, which is to say the levee and floodwall and pumping upgrades completed in the years after Katrina, was designed to protect the city from a 100-year storm surge event. It was not designed to address the failure mode in which the pumps lose power during a non-tropical training storm event. The $14 billion protects against the wrong threat. The threat that the current pattern presents is not the threat the infrastructure was upgraded to handle. That is the gap. A city below sea level, in 105-degree heat, in a power grid stress event, with a training storm pattern overhead and with no functional gravity drainage. The infrastructure cost in the post-Katrina rebuild was directed at storm surge. The current pattern does not require storm surge, it requires the pumps to stay on. And the same pattern that produces the rainfall is the same pattern that produces the heat that stresses the grid that powers the pumps. The next part of this video will move beyond New Orleans to the broader human geography of the corridor, because the elderly population concentration along the Gulf Coast is the lens through which the entire event has to be understood. The pumps in New Orleans are one infrastructure failure mode. The elderly population in older housing across 5 states is another. And the state that gets hit last by this pattern, the state that absorbs the longest portion of the extended hazard window, has the highest percentage of elderly residents of any state in the nation. That state is Florida. The 5 states in the direct path of this event contain approximately 7.2 million Americans aged 65 and older, and the state that gets hit last, Florida, has the highest percentage of elderly residents of any state in the nation. Texas, Louisiana, Mississippi, Alabama, and Florida. 5 states. 1 pattern. A combined elderly population larger than the total population of Massachusetts. And every official forecast document that has been filed for this event has used population-neutral language. The documents describe the geography, they do not describe the people in it. Let me give you the breakdown. Texas, the western anchor of the corridor, has approximately 3.8 million residents aged 65 and older. The Texas elderly population is concentrated in the metropolitan corridors of Houston, San Antonio, Dallas, and Austin, with significant secondary concentrations in the smaller cities along the Gulf Coast and in the Rio Grande Valley. Louisiana adds approximately 750,000 elderly residents, concentrated in the New Orleans metropolitan area, the Baton Rouge corridor, and the smaller communities along the bayou parishes. Mississippi adds approximately 450,000, Alabama adds approximately 850,000, and Florida, the state that closes the corridor on its eastern flank, adds approximately 4.7 million elderly residents. Florida alone has more elderly residents than the entire populations of 14 other states combined. The Florida figure deserves its own frame. 21.3% of the Florida population is aged 65 or older. That is the highest percentage in any state in the United States. It is more than 4 percentage points above the national average, and the Florida elderly population is not evenly distributed across the state. It is concentrated in specific coastal counties along the Gulf side of the peninsula, in the Tampa Bay metropolitan area, in the Fort Myers and Naples corridor, in Sarasota, in Pinellas County, and in the retirement communities of Central Florida that draw their residents from across the country. That distribution matters because of the extended hazard window. The National Oceanic and Atmospheric Administration's Climate Prediction Center has issued a probabilistic hazards outlook that extends the hazard signal across the entire Gulf Coast through June 22 to June 26. The outlook is a separate document from the Weather Prediction Center's 5-day forecast discussion. It looks further out and it carries lower certainty, but it identifies geographic regions where the probability of hazardous conditions exceeds the threshold that triggers the slight risk classification. The current outlook has placed a slight risk signal across the entire Florida peninsula for the June 22 to June 26 window, which is to say Florida gets hit last and longest. The pattern arrives over the western Gulf Coast first, in Texas and Louisiana, in the early portion of the event window. It propagates eastward across Mississippi and Alabama through the middle days, and it terminates over Florida, where the extended hazard outlook keeps the threat signal active for an additional 5 days after the initial event window ends in the west. A retired couple in Houston experiences the event from approximately June 16 through June 21. A retired couple in Tampa experiences the event from approximately June 18 through June 26. The same pattern. Different durations. The state with the largest elderly population concentration receives the longest exposure. Let me explain the physiological mechanism for why this matters. The human body's cooling system relies on two primary mechanisms. The first is the dilation of blood vessels at the skin's surface, which increases blood flow to the periphery and allows internal heat to radiate outward. The second is the production of sweat, which cools the body through evaporation. Both mechanisms degrade with age. The cardiovascular system loses elasticity, which reduces the body's ability to redirect blood flow rapidly in response to heat. The sweat glands produce less sweat per unit of skin surface area, and the threshold at which sweating begins rises. The body's perception of thirst also degrades, which means elderly adults often do not feel thirsty until they are already significantly dehydrated. The combination of these degradations means that an elderly adult at 105 degrees heat index can begin to experience heat stroke within 20 to 30 minutes of sustained exposure. 20 to 30 minutes. That is the timeline. Not hours, not a full afternoon. Minutes, and the heat index in the current forecast is expected to reach or exceed 105 degrees across multiple counties for sustained windows of 6 to 8 hours per day, for 5 consecutive days in the western half of the corridor, and for 10 consecutive days in the Florida Peninsula. Now factor in the housing stock. The Gulf Coast contains a significant percentage of older homes built before modern insulation standards, with single-pane windows, limited attic ventilation, and air conditioning systems that were installed decades ago and have not been upgraded. The pre-1980 housing stock on the Gulf Coast represents approximately 30 to 40% of the residential building inventory across the 5-state corridor. In older urban neighborhoods, in rural parishes, and in the inland communities that did not benefit from the post-Hurricane Andrew housing code upgrades, the percentage runs higher. These homes do not hold cool air well. They absorb heat through the walls and roof during the day, and they release that heat into the living space at night. They are heat traps. An elderly resident in an older Gulf Coast home, during a hazardous heat event with a window unit air conditioner that was installed 20 years ago and has not been serviced in 5, is sitting inside an environment that cannot cool below a specific threshold. That threshold is determined by the outside air temperature, the humidity, the insulation level of the building, and the capacity of the cooling unit. During a normal heat event, the threshold sits around 78 to 80 degrees. The body can rest at that temperature. During a hazardous heat event with overnight lows in the 80s and outside daytime temperatures pushing the heat index above 105, the threshold rises. The cooling unit cannot keep up. The inside temperature drifts upward. By day 3, the bedroom is 85 degrees overnight. By day 4, 87. By day 5, the system fails entirely. This is not a hypothetical scenario. The 1995 Chicago heatwave killed 739 people. The 2003 European heatwave killed over 70,000. The 2021 Pacific Northwest Heat Dome, which is the calibration event for the current ridge, killed at least 868 people across British Columbia, Washington, and Oregon. The Pacific Northwest deaths were concentrated in elderly adults living alone in older housing without adequate air conditioning. Multnomah County, Oregon, which contains the city of Portland, conducted a detailed mortality review and found that the median age of the heatwave descendants was 71, and that more than half of them died alone in their homes. That is the model. That is the demographic. That is the mechanism. Let me give you the named person frame. In the Pacific Northwest Heat Dome of 2021, a woman in her 70s living alone in a small apartment in suburban Portland, with a window unit that could not keep up with the heat, was found by her adult child 2 days after the peak of the event. She had not been answering her phone. Her child drove from a neighbouring state. The apartment was over 110 degrees inside. She had died sometime in the previous 48 hours. Her name does not need to be in this script for the story to do its work. The pattern of her death is the pattern of nearly every elderly heat death in the United States in the past 3 decades. She lived alone. She did not feel thirsty. The cooling unit did not keep up. No one checked on her until it was too late. The Gulf Coast contains approximately 1.8 million elderly residents who live alone. That is a quarter of the total elderly population in the 5-state corridor. It is a population larger than the entire population of the state of Nebraska. And the demographic that is most at risk during a hazardous heat event is also the demographic most likely to have no one in the house to notice when the cooling fails, no one in the family to call when the heat index reaches 110, no one in the neighbourhood to walk over and check. That is who this event is targeting. Not statistically. Operationally, the pattern is over the geography where the population lives. The geography contains the housing stock that traps heat. The housing stock contains the population that is physiologically most vulnerable. The population includes the subset that lives alone. And the forecast extends through 10 consecutive days across the Florida Peninsula, where that subset is largest. The Weather Prediction Center filed the operational language. The Climate Prediction Center extended the hazard window. The Gulf at August temperatures eliminated the recovery window. The grid will be stressed. The pumps may fail. And the people who will absorb the worst of what this pattern does are the people who, as of this moment, have no one calling to check whether they have already turned the air conditioning down to save money or stocked enough water for 5 days. The forecast did not name them. But the geography did. Part 7 ended with a question about the people who live alone, the ones no one is checking on. And the answer to that question depends entirely on how long this event actually lasts, which means it depends on a number that almost every outlet covering this story has gotten wrong. The number is June 21. That is the date the mainstream coverage has used as the end of the event. Every cable news weather segment, every wire service summary, every metropolitan newspaper weather page has used some version of the phrase through the weekend or into early next week or by Sunday to define the end of the event. June 21 is the operational shorthand for that timeline. The number is wrong. The National Oceanic and Atmospheric Administration's Climate Prediction Center Probabilistic Hazards Outlook, which is a separate official document from the Weather Prediction Center's 5-day forecast discussion, extends the hazard signal across the entire Gulf Coast and the full Florida Peninsula through June 22 to June 26. That is 5 additional days beyond the date the mainstream coverage has reported. The CPC Outlook is a publicly available document. It is filed by the same agency that filed the WPC discussion. It is not a competing forecast or an alternative model. It is the official extended outlook from the federal agency responsible for monitoring climate scale and seasonal scale hazard signals. The mainstream coverage did not use it. That is not the forecast clearing. That is the forecast continuing under a different name. Let me explain the structure of why this happened. The Weather Prediction Center issues forecast discussions and quantitative precipitation forecasts on a short timeline, typically out to 5 days. The Climate Prediction Center issues probabilistic outlooks on longer timelines, typically 6 to 10 days, 8 to 14 days, and seasonal. The two centers are part of the same agency, the National Weather Service, but they file their products separately and on different distribution lists. Local broadcasters typically pull from the WPC short-range products because those products feed directly into the regional forecast offices that produce the daily weather graphics. The CPC longer-range outlooks require a separate query and are not part of the standard local broadcast pipeline, which is to say the longer the forecast window, the less likely it is to reach the evening news. The June 14 WPC discussion ran out to June 19 in its detailed quantitative section. The same document referenced the CPC outlook for the period beyond June 19. The mainstream coverage truncated the event at the end of the WPC quantitative window. The CPC outlook, which extended the threat signal another full week, sat in a separate document that was not pulled into the broadcast cycle. That is Gap 2. But the Gap 2 story is not just about the documents. It is about a structural climate signal that was confirmed 3 days before the WPC discussion was filed. And that gives the entire pattern a different shape than a 1-week event. On June 11, 2026, the Climate Prediction Center officially declared the onset of El Niño conditions in the equatorial Pacific Ocean. The El Niño Southern Oscillation, which is to say the periodic warming of the central and eastern equatorial Pacific that fundamentally restructures global atmospheric circulation, had crossed the threshold required for an official declaration. The temperature anomalies in the NEO 3-4 region, which is the central equatorial Pacific monitoring zone, had exceeded plus 0.5 degrees Celsius above the long-term average for the required duration of consecutive months. El Niño had been declared, and the same CPC bulletin that announced the declaration carried an additional forecast. The probability that the current El Niño will develop into a strong event, defined as plus 1.5 degrees Celsius or greater anomaly in the Neo 3, region by the late summer or early fall, was assessed at 63%. The probability of a very strong event, defined as plus 2.0 degrees Celsius or greater, was assessed at 31%. The combined probability of a strong or very strong El Niño this summer and fall stood at well over half. That is not a minor climate footnote. That is a structural reframing of the entire summer. El Niño years carry specific atmospheric signatures across the southern United States. The most consistent signature is a southward shift in the jet stream during the late summer and fall months, which produces above normal precipitation across the Gulf Coast and below normal precipitation in the Pacific Northwest. The summer signature is more variable, but the early El Niño summers of the past century have been characterized by persistent ridging across the southern United States, by elevated Gulf sea surface temperatures, and by a more active early storm season in the Western Gulf. Every one of those characteristics is documented in the current pattern. The Climate Impact Company, which is the private climate analysis firm that issues commercial forecast products to the agricultural and energy sectors, published an assessment in early June that described the projected ridge over the southern United States as having semi-permanent characteristics through late June and into July. If you are an emergency manager mapping out cooling center logistics, or a paramedic in Mobile, that phrase is the one that tells you your local infrastructure is about to be tested beyond its design limits. Semi-permanent, in the operational language of that assessment, means a ridge that re-establishes itself after temporary disruptions, that resists displacement by transient weather systems, and that maintains its general position over the same geography for multi-week durations. Do not move past that definition, because it is the exact mechanism that turns a bad week into a catastrophic season. That assessment was published before the June 14 WPC discussion. It was published before the El Niño declaration. And the pattern it described has materialized exactly as projected, so the June 21 end date is not just imprecise. It is misleading at 3 layers. The first layer is the CPC outlook layer, which extends the hazard signal another 5 days beyond the WPC quantitative window. That alone moves the end date to June 26 at minimum. The second layer is the semi-permanent ridge layer, which the Climate Impact Company assessment describes as persisting through late June and into July, with periodic re-establishment after transient disruptions. That moves the structural end date into mid-July at minimum. The third layer is the El Niño layer, which restructures the entire summer and fall atmospheric configuration in ways that favour continued ridging across the Gulf South, elevated Gulf sea surface temperatures, and an active storm season feeding off those temperatures. That layer does not end. It defines the season. That is not the end of a heat week. That is not a forecast deadline. That is the beginning of a summer under an El Niño that NOAA has given a 63% chance of becoming one of the strongest atmospheric setups in 75 years, and the Gulf Coast is directly in the centre of it. Let me put that 75-year number in context. A very strong El Niño, with central Pacific anomalies exceeding plus 2.0 degrees Celsius, has occurred a small number of times in the recorded climate history that extends reliably back to the mid-20th century. The 1982 to 1983 event, the 1997 to 1998 event, the 2015 to 2016 event. Each of those events produced specific signatures across the United States. Each of those events lasted into the following calendar year. Each of those events restructured the global atmospheric circulation in ways that affected agricultural yields, fisheries, water supplies, and severe weather frequencies in ways that the public did not fully understand until the events were over. A 63% probability of joining that list is not a small number. It is a structural climate signal that the current week is the opening act of, not a contained event with a Sunday end date. And here is what that means for the elderly population question that Part 7 left open. If the event ends June 21, the people who live alone need to be checked on for 5 days. If the event ends June 26, the check-in window is 10 days. If the ridge ray establishes through late June and into July, the check-in window extends through the summer. If the El Niño produces the projected continued ridging and elevated Gulf temperatures, The check-in pattern is the new baseline for the season. The same 1.8 million elderly residents who live alone are not facing a 5-day event. They are facing a season. And the same training storm mechanism that the June 14 discussion named is not a 1-week threat. It is the operating condition of the corridor for the foreseeable summer. Every transient storm system that crosses the Gulf during this period will draw moisture from water that is already at August temperatures. Every disturbance will have the potential to develop into a training storm event under the pattern overhead. The threshold for a flash flood event in any given Gulf Coast city is lower this summer than it was last summer, and it will remain lower for as long as the El Niño signature drives the pattern. That is the seasonal frame. The September question is the one that closes this part, and it is not rhetorical. The Atlantic hurricane season runs from June through November. The peak of the season is mid-August through late October. By September, the Gulf will have absorbed 3 additional months of solar heating on top of the elevated baseline it is currently running. The atmospheric pattern that drives storm development will have continued to operate under the El Niño signature. Any tropical system that enters the Gulf in September will be entering water that is hotter than it has historically been, under an atmospheric configuration that favours stalling, with the same mechanism documented in the June 14 forecast discussion still operationally active. If this is the opening act, what does September look like? The answer is in the document. The mainstream coverage has not pulled it. The next part of this video will give you the specific actions to take in the next 72 hours. The 4 signals that tell you the threat has crossed from forecast to active event, and the one daily action that matters more than every other preparedness item combined. Let me walk you through exactly what to watch for in the next 72 hours. 4 specific official signals that tell you the forecast has crossed from warning into active event, and exactly what to do before any of those signals appear. The signals are not generic emergency messaging. They are operational triggers that the agencies use to escalate their own response, and when you see them issue, the threat level has changed. Signal 1 is the National Weather Service Excessive Heat Warning issuance. The current event has been classified at the hazardous tier in the Weather Prediction Center discussion, but the public-facing excessive heat warning issuance has not yet propagated across all regional forecast offices. When your local NW's office, which you can find at weather.gov by entering your zip code, upgrades from a heat advisory to an excessive heat warning, the operational threat has moved from elevated to immediate. Watch that document, not the local broadcast, the actual NW's office page. Signal 2 is the National Hurricane Center upgrade to 30% or higher. The Gulf disturbance that mainstream coverage has referenced has been monitored by the National Hurricane Center with a low probability of tropical development through the 7-day outlook. If that probability is upgraded to 30% or higher, the disturbance has crossed the threshold where it is likely to produce organized convection that can interact with the training storm mechanism overhead. The NHC outlook is updated every 6 hours and is publicly available at nhc.noa.gov. Signal 3 is training storm confirmation in real-time radar imagery. This signal is not a document, it is a pattern. When the local radar shows multiple storm cells forming along the same line and moving along the same track for 2 or more consecutive hours, the training mechanism is active. The signal is visible on any free radar product, including the NW's radar at radar.weather.gov. The pattern looks like a string of beads moving along a single line. When you see that, the mechanism the June 14 discussion named is occurring over your geography. Signal 4 is ERCOT or Mesogrid stress alerts. ERCOT is the grid operator for most of Texas. MESO is the regional transmission organization for the central United States, including Louisiana. Both operators issue public grid stress alerts when electricity demand approaches the limits of available supply. The alerts are escalating tiers, from conservation appeals through to emergency operations. When either operator issues an alert above the conservation appeal tier, the grid that powers the air conditioning and the pumping stations is approaching failure conditions. Both operators publish their alerts on their websites and through emergency broadcast channels. Those are the 4 signals. Now here is what to do before any of them are issued, because the right time to prepare is the 72-hour window when the forecast has been filed but the alerts have not yet escalated. Action 1. Test your air conditioning today, not the day you need it. Set the thermostat to 72 degrees and let the system run for 1 hour. If the indoor temperature does not drop to 75 degrees within that hour, the system is not adequate for a hazardous heat event. Call an HVAC service today, not on day 3. The final thing this story leaves you with is not a checklist. It is the image that started it. 3 words in a government document. The same 3 words that sat in the Harvey forecast before Houston flooded. This time the words sit beside hotter Gulf water, a wider threat corridor, and a pattern that has not yet finished moving. That is why the warning matters now, before the rain begins. The daily action through the event window is the one that matters more than every other item on this list combined. Physically check on one person in your geography who lives alone every single day for the duration of the event. Not by phone, by presence. Walk to the door. Knock. Confirm that the person is responsive, that the air conditioning is running, that water is available, and that the person knows the event is ongoing. One person. Every day. In person. Until the event ends. That is the action that closes the gap. The forecast did not name the elderly Americans in the corridor, the geography did, and the only thing that closes the distance between a forecast that names no one and a population that contains the people most likely to die is a neighbour walking to a door. But to understand why this action is necessary, you have to see what the agencies see when they zoom all the way out. Every data point in this video, the hazardous heat classification, the training storm mechanism, the 80-degree Gulf water, the 1,500-mile threat corridor, the El Nino declaration, the June 22 to June 26 hazard extension, traces back to a single atmospheric driver confirmed in a single government document released on a single day. The driver is the highly anomalous upper air pattern described in the June 14, 2026 Weather Prediction Center forecast discussion. One pattern, one document. 6 major data points that the mainstream coverage reported as 6 separate stories. That is the institutional gap in its fullest form. The Iowa flood coverage did not mention the Gulf heat. The Gulf heat coverage did not mention the Iowa flood. The Florida humidity coverage did not mention either of them. The El Nino declaration was buried as a climate science footnote in coverage that did not connect it to the current event. The CPC extended outlook sat in a document that no broadcast pulled from, and the Climate Impact Company's semi-permanent ridge assessment was published as an industry briefing that did not enter the public news cycle. 6 pieces of one picture. 6 separate stories, none of them mentioned each other. The American Meteor Society and the National Weather Service Flash Flood Research Program, both of which study the relationship between operational forecast language and public response, have documented this pattern. When a single atmospheric driver produces multiple downstream effects, the public coverage tends to treat each effect as its own story. The driver itself rarely makes the broadcast because the driver is invisible. It sits in the upper troposphere. It does not produce dramatic local footage. It does not have a name. It does not generate a Saffir-Simpson rating. It is the pattern overhead, and the pattern overhead does not photograph well. But the pattern overhead is what produces everything you have seen reported this week. The heat is the ridge, the Iowa flooding is the trough. The Gulf moisture flow is the conveyor belt between them. The training storm threat is the convergence zone where the conveyor belt meets the heat dome's southern flank. The elevated Gulf temperatures are the fuel that the conveyor belt loads into every storm cell that crosses it. The El Nino is the structural climate forcing that holds the entire configuration in place across the summer, and the CPC outlook is the official acknowledgement that this configuration will not dissipate by the date the public has been using as the endpoint. One driver. 6 effects. One season. Let me give you the widest frame this video will offer. The historical record of compound atmospheric events in the continental United States contains a small number of patterns that combined hazardous heat, training storm flooding, elevated regional water temperatures, and a continental scale threat corridor under a single driver. The 1980 heatwave. The 1995 Midwest heatwave. The 2011 Texas drought and heat event. The 2012 Midwest drought. The 2021 Pacific Northwest heat dome. Each of those events was driven by a stalled atmospheric pattern. Each produced cascading effects across multiple regions. Each was reported as a series of separate stories during the event and only understood as a unified system after the event was over. The current pattern fits the historical signature. The historical signature is identifiable in the operational documents while the event is still in progress. The June 14 WPC discussion described it. The June 11 CPC bulletin extended it. The Climate Impact Company assessment projected it before it materialized. The signal was available. The integration was not performed in the public coverage. That is the question the next part closes, and it is not rhetorical. The question is no longer whether this week is dangerous. The question is whether we are at the beginning of a pattern or in the middle of one. The mainstream coverage has answered that question implicitly by treating the event as a contained week. The operational documents answer it differently. The El Niño signature, the semi-permanent ridge assessment, the August Gulf temperatures in June, and the extended hazard outlook collectively describe a pattern that the agencies that monitor it expect to persist through the summer and possibly through the fall. The mainstream coverage has reported one slice of the atmospheric configuration as the whole story. The operational documents do not describe a contained heatwave with a Sunday end date. They describe the configuration itself. The slice is real, but the configuration is far bigger, and what it implies for the rest of the season leads us directly to the final missing piece of this forecast. And the final part of this video will close the loop that the hook opened. The 3 words from the August 2017 forecast discussion. The same 3 words in the June 14 document. The mechanism that produced 60 inches of rain on a single American city. The geography that absorbed it. And the question of what happens when the same words appear again, in the same kind of document, with the same kind of mechanism, in the same kind of geography, under water that is hotter than it was in 2017, and under an atmospheric configuration that the agencies have given a 63% chance of being one of the strongest in 75 years. The pattern recognition is not a prediction. It is a recognition. And the recognition is yours now. We started this video with a question, not whether this week is dangerous, but why the same warning that preceded Harvey is sitting in a government document right now, and why you had not heard about it until this moment. The answer is now in front of you. The 3 words are repeat and training of storms. They appeared in the National Weather Service forecast discussion in the 72 hours before Harvey's worst rainfall began to accumulate over Houston. They did not appear in a single news broadcast in that window. The document was publicly available, the mechanism was named, the geography was identified, and the chain of translation between the operational document and the evening news softened the language into a tropical storm narrative that obscured the mechanism that actually produced the rainfall. Those 3 words are in the document again. The June 14, 2026 Weather Prediction Center forecast discussion contains the same phrase, the same operational language, the same agency, the same Gulf Coast geography. And as of the publication of this video, the same chain of translation has filed the language out of public reach. No broadcast has read it, no wire service has quoted it, no local meteorologist has held up the document and pointed at the sentence. That is the structural parallel. This is not a prediction. This video has not told you that the events of August 2017 are about to repeat themselves. The future is not knowable in operational meteorology. What is knowable is the pattern. The mechanism that produced Harvey's rainfall is named in the current document. The water that fed Harvey's rainfall was cooler than the water that sits in the Gulf right now. The atmospheric configuration that allowed Harvey's training storms to stall over Houston is documented as semi-permanent across the current corridor through late June and possibly through July. The El Niño signature that restructures atmospheric circulation has been declared. The CPC outlook extends the hazard window through June 26 at minimum. The conditions are documented. The mechanism is named. The geography is overlapping. That is the pattern recognition. A pattern recognition is not a prophecy. It is the ability to see a configuration that has produced a specific outcome before and to understand that the same configuration is now in place. The outcome may differ, the geography may shift by miles, the total rainfall may concentrate over a different city, the training storm cells may stall over a different metropolitan area. The variables that determine which specific neighborhood absorbs the worst of the event are not predictable from the forecast discussion alone. What is predictable is the mechanism, and the mechanism is named. The agencies that filed the documents know this. The forecasters who wrote the discussions know this. The emergency managers in FEMA Regions 4, 6 and 7 know this. The grid operators at ERCOT and MISO know this. The hurricane researchers at the National Hurricane Center know this. The climate scientists at NOAA know this. The hydrologists at the United States Geological Survey know this. The pumping station engineers in New Orleans know this. And now you know this. That is the gift this video offers. Not a prediction and not a panic. It is a pattern reading based on the documents filed so far. The gift is the language. The 3 words. The mechanism. The document. The geography. The chain of translation that softened the operational language into a broadcast narrative. The understanding that the broadcast narrative is calibrated to a different event than the document describes. The recognition that when the broadcast next week says the heat is breaking, the document may say the pattern is reorganizing. And the knowledge that the difference between those 2 sentences is the difference between safety and the absence of preparation. They do not know what. They do not know why. They do not know when it will stop. In August 2017, the people who lost their homes and their lives did not know what was sitting in the official forecast. The broadcast coverage had not given them the language. The translation chain had failed them. They faced a catastrophic atmospheric mechanism with nothing but a tropical storm narrative to protect them. The 3 words that could have changed their preparation sat in a government document, quietly predicting the reality they were about to endure. Those same 3 words are in a government document right now, predicting the exact same mechanism for the exact same geography. The warning is written. The pattern is locked. The only difference between then and now is that this time, you have heard it.